On board our rigs, the transfer systems look like a maze of pipework, and that can be intimidating to some people. But they're really relatively simple once you understand the principles behind them. There are two basic transfer systems that we'll be referring to. First will be the bulk mud transfer systems that move the bulk powdered products like barite and bentonite from one place to another. The second one is the equipment and piping system that directs fluids, mixed mud, from tank to tank and down the hole. We'll start off with the bulk transfer systems. Piping for the bulk system is going to be a little different on each of our rigs, but the principles behind the operation of each system are always the same. They operate on a system that can best be described as a one-way highway for powdered products. The piping system can be broken down into 5 basic categories: the fill line system, the discharge line system, the purge line system, the air supply system, and the vent line system. The fill line is used to fill the tanks. This is the line that bulk is transferred through to its destination. They originate at the port and starboard sides of the rig. This is the connection that supply boats hook into to offload bulk materials, products like bentonite, barite, and cement. As a derrick man, you'll probably never have to deal with the offloading operation, but you need to be aware that this operation occurs. Whenever a P-tank is being loaded from a supply boat, it can't be used for transferring materials. There are a series of valves along the route. These valves direct the bulk to any of the tanks along the line. For any particular tank that should be filled, a pathway is opened between the source tank and the destination tank by opening the proper valves. Once this is done, the bulk has an open path to move within. The discharge line is used to move bulk from the P-tanks to the surge tanks or to other P-tanks. You might notice that the fill lines operate from the top of the P-tanks and the discharge lines operate from the bottom. There's always a union where the two lines are joined together. This allows the material that's routed into the discharge line system to be routed to the fill line system, which in turn delivers the materials to the various tanks. Naturally, powders can't be pumped like liquids are, but they can be transferred with airflow. Our airflow system works a lot like a vacuum cleaner, only in reverse. Instead of sucking, it blows. This is how this transfer system operates. An air supply is used to move the powder from tank to tank. These transfer systems are designed to operate at specified pressures. The pressure is controlled with a regulator system, and the exact pressure for your rig is the responsibility of your barge engineer. You shouldn't be changing it without his full knowledge and endorsement. We'll talk specifically about the pressures of your system and how it affects the way that the system operates a little later. To move materials, an open path has to exist from the source tank to the destination tank. An airflow is established between the two. Air, supplied by the air system, is blown into the bottom of the source tank. The tank has to be charged up to the operating pressure of the system before materials can be transferred, and this can easily take a half hour or longer. While it's charging up, you can line up all your other valves. Everything should be closed to start out. The first thing that's opened is the vent line at the destination tank. This will allow the airflow to be established once all the other valves have been opened. The air generated at the source tank will travel through the system as you have it routed. Then it will be vented overboard from the destination tank. When the pressure in the source tank has reached its operating pressure, the proper valves can be opened to direct the material from the source to its destination. Before opening the discharge valve, get your airflow started by opening the purge air at the source tank. Then, when you open the discharge valve, bulk will flow from the source tank, through the fill manifold, and into the destination tank. At the destination tank, the air vents overboard, leaving behind the bulk materials. Once the material has been transferred, the source valve is closed, but the purge valve is left open for about 10 minutes to blow the residual bulk out of the lines so that it doesn't settle in the lines and clog up. When the transfer is complete, all of the valves are closed and the pressure is bled off of the source tank through its vent valve. Now let's watch a derrick man go through the procedures of transferring some barite. This is on the Sedco 471, so your system will probably be laid out a little differently. Starting out, all valves are closed off. The easy way to tell by looking whether or not a valve is open is to notice the position of the handle. If the handle cuts across the direction of the pipe, it's closed. If it lines up with the direction of the pipe, it's open. First, we open the air supply into the source tank. You should be able to hear the air flowing. There's generally a pressure gauge that will tell you when it's at full pressure. If the bulk tank is pretty full, it won't take too long to pressurize. If it's low, though, it could take up to a half hour or more. Next, the vent valve is opened at the destination tank. On this rig, this valve is operated remotely from a panel, since the vent valve is on another level. Then, all of the pass-through valves from the source tank to the destination tank are opened, except for the valve at the bottom of the source tank. The purge line is turned on to get an airflow established. Once the source tank reaches pressure, the source valve is opened and bulk starts to move from one tank to the other. A weight indicator on the surge tank tells how much bulk has been transferred, so when the required amount has been moved, the source valve is shut off. The purge line is left open for about 10 minutes to purge the residual bulk out of the lines. Once this has been done and the purge line has been closed, all other valves are closed and the pressure is bled off of the source tank through the vent valve. Moving bulk is no more complicated than that, but there are some problems you can encounter. The most common one is a plugged line. Plugged lines occur usually because of moisture in the air system or condensation in the lines. The transfer air usually comes from the rig's air supply system. Water condenses in these lines pretty easily. There's supposed to be a drying system to dry the air out before it enters the system, but sometimes when the dryer isn't operating right, moisture can pass through with the supply air. About the only way to get a plugged line unplugged is to find the location of the plug by rapping the lines until you hear a dull thud. Then put purge pressure behind the clog and open a vent valve. If you rap it hard enough to set up vibrations inside the pipe at that point, the purge air behind the clog will carry the material off as it dislodges.
We don't make it a practice of hammering on pipes, but it is a good method of locating the blockage, and by tapping the pipe you may get lucky and go ahead and break it loose.
Some people have been known to readjust the regulator in the air supply to increase the pressure, thinking they'll blow the plug out. They may blow the plug out, but they'll also blow the rupture disc out too. The rupture disc is this little device that ruptures when your operational pressure exceeds the rated pressure of the system.
This is a rupture disc. It is designed to rupture at 39 psi. In each of our 8 P tanks, we have one of these rupture discs inserted. So great care should be taken when allowing the flow of air to enter the P tank, for too much volume will cause this disc to rupture, and also over a prolonged period of time, too much pressure will result in the same.
Some rigs use pressure relief cocks, but both serve the same purpose. They're safety devices that are on most of our systems to keep you from blowing the system up. These systems are designed to operate only at one pressure. Design engineers spend a lot of time figuring out what the maximum safe operating pressure is, so don't be second-guessing them. Don't ever increase the pressure on these systems beyond the rated specifications. If you get a plug, use the old standard methods. If this doesn't work, go get the barge engineer and let him help you. You might be able to use a plumber's snake, or you may have to do something as drastic as cut a section of pipe out to clear it. But that's safer than trying to bulldog it out with air. Another common problem that'll result in a plugged line is low operating pressure. The operating pressure is important because most of our systems operate on fairly low pressures, in the 30 to 40 psi range. If the pressure drops much below that, the system will tend to clog. It's real important that you not operate the system above these rated pressures, but it's just as important to make sure you've got enough pressure. Another thing that might cause clogs is the failure to purge the lines good enough after transferring product. If any bulk is left in the lines, it'll settle into the pipes and could plug the lines, especially if there's a little bit of water puddled up somewhere. That's why we've told you to purge the system for 10 minutes after you transfer. One of the duties that you'll be responsible for is tallying out how much bulk product you have used in a tower. In Part 4, we tallied out the totals used for the day. We didn't talk about determining how much bulk remains in the tanks. The company man's going to be real interested in this, so the derrick man had better know. It's pretty easy to simply keep track of what you transferred from each tank to the surge tanks, but this isn't really very accurate. At the end of your tower, you need to check the tank or tanks you've been transferring from to see how much physically is left in them. This is called sounding the tanks. The term comes from the old technique of determining the bulk levels of these tanks. The derrick man simply pounded on the tanks until the dull thud turned into a ringing sound. Then the number of steps were counted up to that level. Each step is about a foot, and the level was recorded. On some rigs, this technique is still used, but it's not all that accurate, and it could damage the tank, so we don't recommend it. You really can't see the true level inside the tank with this method either. You might be measuring a low spot in the tank, or a high spot. What you really want is the exact level. Exact levels aren't that hard to get if you sound the tanks properly. Here's the procedure. The first thing you'll need to do is to fluff the tank. When the tank is fluffed, all that you're really doing is unpacking the contents. They'll tend to settle and pack in because of the rig vibrations. When it's fluffed, it will generally distribute the bulk more evenly inside the tank. This will give you a more accurate measurement of the level of the tank. Fluff the tank by opening the vent valve, then opening the air supply valve at the bottom of the tank. This will blow air through the powder and literally fluff it up. It's a good idea to fluff all these tanks every day because the powder will begin to pack in tight from the constant rig vibrations. If it gets too packed, it could pack hard and make it a problem to transfer. The way most of our derrick men are sounding the tanks today is a little better than the old hammer technique. On many of the rigs where the tanks are below deck, it's even easier to do because you don't have to climb all the way down to the bottom of the tank. All you have to do is, first, make sure that the vent valves for the tanks you'll be checking are open and all the pressure is bled off. Leave it open while you're sounding the tank. On most of our tanks, we have either one of these inspection ports that you can use to lower a sounding line down, or yours may have one of these quick-release access hatches. Either way, you simply lower your line until you feel the weight come to rest on the bulk. Sam here is using a homemade device with a knot tied at 1 foot intervals. As he pulls the weight up, he counts the number of knots. This is a graduated sounding line. It's a lot easier to use because you can tell the level just by looking at the scale on the tape measure. You'll probably want to use a flashlight to look down into the port to make sure that the level is pretty even. Once you've got your measurement, be sure to secure the port. Back in the mudroom, you'll have a chart that'll give you the amount of bulk in that tank by equating it to the level. All of the tank's volumes are known and should be written down someplace in the mudroom. Figure each tank and keep records in the mudroom as to the levels and weights of each one. Report these levels at the end of your tower for the drilling report. There's one more area that you'll have to be familiar with as a derrick man in the mudroom. That is, the system that transfers the liquid muds from tank to tank and to the mud pumps. Each system will be different on each of our rigs, but there are enough common things about them to allow us to talk about them and hopefully help you understand them. Let's take a close look at this maze of pipework so you can understand it a little better. Just keep in mind that these pipes and valves are here to allow you to feed fluids from any part of the system to any other part of the system. We'll start at the tanks. At the bottom of each tank, you'll find at least 2 large diameter pipes and gate valves. Some will have 3. One of these 2 pipes will be connected to another large diameter pipe that runs the length of the tanks, and all of the other tanks will be tied into it. This pipe is called a suction manifold. Trace the pipes further, and you'll find that there are 2 routes of interconnecting pipework that tie the manifold to each of the 2 high-pressure mud pumps. One route passes through a low-pressure centrifugal pump called a charging pump before connecting to the input side of the mud pump. This pump is used to charge the high-pressure mud pumps to get them started. The other valve from each tank connects to another suction manifold that we'll call the transfer manifold. and it ties directly to two other low-pressure centrifugal pumps called mud mixing pumps. These mud mixing pumps output to a series of pipes and valves that allow you to direct the fluids to either the mud jets in the mixing room or directly to any one of the pits. Now you'll notice that both suction manifolds have valves that allow you to isolate the manifolds into two separate halves. This is done to allow you to use the manifolds to route fluids along two separate routes at the same time. On several of the tanks, like the active tank and the reserve tank, there might be a third and fourth valve. These are generally tied to pumps that route the mud to a degasser or to the cleaning equipment that we talked about back in Part 1. Now, routing fluids through the system looks complex, but it's really not. All you have to remember is that somehow there is a way to route fluids from any source in the system to any destination in the system. In fact, if you plan carefully, you can separate the manifold and run fluids from two sources to two destinations simultaneously. But you have to think the routing out first. Let's move some mud around and see how it works. Start off by making sure that all valves are closed. Gate valves are closed when the stem in the center of the handle is down and open when the stem is up. Butterfly valves are closed when the direction of the handle cuts across the direction of the pipe, and open when the direction of the handle lines up with the direction of the pipe. Let's say we want to move mud from the active tank to the number 1 mud pump. Simply open the valve at the bottom of the active tank that connects it to the suction manifold for the high-pressure mud pumps. Open the valve to the suction side of the charging pump. Open the valve to the pressure side of the charging pump, and you're ready to charge the intake side of the high-pressure mud pump. Now let's move some mud from the kill tank through the mud jets and then back to the kill tank for weighting up. Again, make sure that all valves are closed so that flow isn't established to some place that you don't want it. Open the valve that connects the tank to the transfer manifold. Then, open the valve at the suction side of the mud mix pump. Open the output valve. Then locate the line that goes to the mud jets. Open that valve. On the output side of the mud jet, open the valve that flows mud back to the kill tank. It's that simple, on paper. Now let's watch someone do the same thing on our system.
After getting the weight material over to my surge tank, now I'm going to have to weight up my kill pit to get a pit of kill mud. I have my suction valve open with all the other suction valves to the various pits closed. The pump I'm going to use is mud mixing pump number 1, which is located right here. I'm going to be drawing mud from my kill pit through this suction valve, through this 12-inch line. The route it's going to be taking is coming through the line. It'll be coming through this smaller line. The mud will go right here and dead end because the valve is shut. It'll come back and it'll go through this route here. Continuing on, it'll go all the way through this line, around this L, back into the centrifugal pump. When I turn the pump on, it'll then be discharging through my discharge manifold, which is this entire system here. This system enables you to transfer mud with any pump that you have to any pit, to various spots on the rig. The way I've got it lined up is after it's being drawn through the centrifugal, it'll be discharged through this line here, which is the line to my hopper system. You'll notice these valves here are open. This valve here is closed, which stops any discharge from going any further. It isolates it. It'll be continuing through this line, going through here, coming around through my hopper. It contains the weight material, going through this manifold. This valve is shut. This valve is open, going through the mixer. I can add my weight material here, and then when it's discharged, it goes through these valves, which are open, goes through the bulkhead, which goes into the pit room. Once I have it into the pit room, it's just a matter of opening up a discharge valve back into my kill pit, which circulates the mud. It's sucked from the kill pit. It's being treated with weight, which will increase the weight, and it's being discharged back into the kill pit.
The one thing to remember here is not to start any of the centrifugal pumps until you have your routing system set up. You don't want to run these centrifugal pumps dry, and you don't want to restrict the output. The best way to learn the system is to go out there and practice lining up your flow from different source tanks to destinations. Don't wait until you're under pressure from the driller to do your learning. Learn the system ahead of time and get comfortable with it. That wraps up this series on mud. Don't go away thinking that you know all you need to know, because this series has just given you a good introduction to water-based muds. You haven't learned anything yet about oil-based muds or emulsified systems, so you have a lot more to learn. But there are other materials you can refer to in better preparing yourself for your job as dairyman. Good luck.